G'day. So this is my solar shared and ham radio project. So we're getting to the stage where we want to put some web services around the functionality that I built into the Raspberry Pi. So for that I'm going to use Apache as the front end. It's going to talk through WSGI, going to wrap Flask, and Flask is going to talk to a Python program that's actually going to have the code for the web services. So once all that's put together and I've got the web services, that's probably going to be this video, and then following video I'll look at putting together a fairly lightweight Angular front end to actually have a nice user interface for things like seeing the Renogy history, what the current status is, and turning on things like the webcam and the ham radio. So just before looking at the code, let's have a look at the main files I'm using. So under my Pi folders, so home, Pi, solar, these are the directories we looked at before. So the actual web service files I'm going to put under solarwww folder, and the two files we need to look at is solarwww.py, which actually has the code for the web services, and the solarwww.wsgi, which has information about how to interface to this code using Flask from Apache. I just showed these two directories as well, the shared directory and the logs directory, because the Apache WSGI daemon needs to be able to have access to these folders to update Solar cache and the various log files and read the various log files. But so you'll see when I set up the configuration for Apache what I do to allow them to have access. So the bottom half of this shows you the Apache side of things. So these are the folders and the files that I'm particularly interested in for Apache. So after installing Apache, these should be the default locations that Apache gets installed to. And the first one, and probably the most important one for what we're doing here, is under etc. Apache 2 sites available. There's already a file that will be installed called 000 default conf. And I decided just to modify that rather than make another one, and we'll have a look at what that contains. But basically I'm adding the WSGI interface information into that, so Apache knows where to look to get over here to the WSGI information interface and the web services and the solar www. The other folders that are of interest to me in Apache are this verlog Apache 2, so that's where it puts the error log and the access log. So I was having lots of looks at the error log. I was basically doing a tail on that to see the last errors when things weren't working. And over here in this folder will be useful when I get to the Angular part, this ver www HTML. So this is the default location for HTML files for my site. And out here I'll put the actual Angular app bundle when I make that in the next video. To show you the software that needs to be installed to get this all to work. So that includes Apache, the WSGI module for Apache, and then I need to install Flask. I'll put a detailed description of all this down in the description below. Okay, from my Visual Studio code environment, I'm remoting into the Raspberry Pi. So I've created this file under solarwww. It's called solarwww.py, and this is where I'm starting to test out Flask to, web services first. So there's really just modifications of the Flask Hello World example they give you on their web pages. So I import Flask, I import Renogy, the Renogy class. I've seen that before. I set the app, and then I tell it to show this under a route called /Renogy. And it's for that route it's going to perform this function. So R's being set to the Renogy class, so it becomes an instance of the Renogy class. And by default the Renogy class, when it starts up, pulls the data off the Renogy solar controller, so it gets information about power usage. I create a Python dictionary item here. This is useful because Flask, if you return a dictionary item to it, it shows the results to the web requester as JSON. So I'm going to put these 3 items in there. So the battery capacity, the solar power, and the output power I got from the Renogy controller. So those become separate dictionary items. Then I return that data dictionary. So we should be ready to go. So first thing I need to do to execute this and test out Flask is set the Flask app with an export variable. And then the second thing to do is actually run Flask. So it's Flask run, and then with this host parameter to say it can receive requests from any IP address, not just the IP address of the machine this is running on. By default, it will only respond to requests from the same machine. So that's not easy to do when I've got a remote Raspberry Pi, so I've set it up to accept requests from any host. So let's run that. So it's running, it's telling me this is the URL to use to test it out. So I'm going to actually take that, Control C, bring up my browser. I'll put that in and let's try this one out. So that fails, but remember we set the route to Renogy. So the default route hasn't got any service on it, but the Renogy one does, and here we see it. The information being returned as JSON, which is a useful way to get it for when my Angular application uses this information. Now let's get it, Flask running under Apache. So this is where the solarwww.wsgi file is used. So this defines the environment that Flask is running in when Apache connects to the Flask app. So we import sys, we add these path statements to sys, so adding the path to the solarwww folder, which has the Python program in it, and we're also adding the path to the shared folder, which has the modules that this program's dependent on. And finally, to set up the app as application and point to solarwww. The other thing we need to do is to go into Apache's sites available. I'm updating the default one that's going to be there when you first install Apache. You could create a new one, but I'm using the default one that's there. I'm going to use gedit because I don't have scope in my VS Code remoting to get there otherwise. So this is looking at that configure file through gedit. It's exposed in an Windows application. That's why in my install instructions I say it's good to also install gedit in the related Windows environment as well. So the default config, it's for the virtual host on port 80, which is kind of the default port for websites, and the one I'm going to use. These first 4 lines were already in this file when it was first installed, so the bit I'm interested in is adding this WSGI section to it to tell it how to communicate with a WSGI application, which is our solarwww. This is the name of it that ties to this WSGI process group here. So it's saying for that process, that daemon process, it should run under the user code of Pi and the group of Pi. By default, this will run under www/data, and you saw earlier there's a couple of extra folders that this program needs access to. It needs access to the Solar share and the Solar logs file to for some of the web services it has to execute. But if you run the daemon process under Pi, then it's just going to work as though you're just SSH'd in as Pi and has all the same permissions. Has 5 threads. I don't think I'm ever going to use 5. And then setting up this display name is a useful option as well. So when I do a PS to view the current processes, I can do a greep on this name and see that, find the process that this daemon's running as. I'll set up the script alias. The important bit here is this first parameter here, /. That's just saying that this WSGI application will respond at this level of the URL, and then the location of that WSGI file that we were just looking at describes the environment for Flask. And finally, this directory parameter here. So like I said, this WSGI process group is the name of this process group that we're working on. This bit's important as well. So for later versions of Apache, I think it's 2.4 and above, how you define its access to this directory is different. Before there was a different syntax, but now the syntax is the one you use to give it full access to that directory and the daemon process. So this is all set up. Let's save that, close it out, and we just need to tell Apache to reload, so it applies the new configuration settings. So that should be running now. So we've got Apache connected to the WSGI interface, connected to the solarwww Flask application. Let's bring up my browser, and remember it's HTTP because it's on port 80. The name of the program, the host it's running on, is Solar in this case. And if I just put that in, I'll just get the static pages that site's already set up for. So to get access to the web services, the Flask application, remember in the Python program I said the route is /Renogy. So now when I do Solar Renogy, it executes that Flask app and returns the Renogy information, in this case, as JSON. So it looks like it's all working now. It's been hosted properly under Apache, and that's what I need. So now I can work on the program and add all the other web services that I want. So I want to... Yeah, this is a couple of days later, so I filled in most of the services here. So one thing I did, let's have a quick look at this, is in the default conf, I updated that, and all this information's in a file, and I've got the link down in the description where you can find out how all these things were set up. Down here I went and changed the WSGI script alias to /API, so now all these API Flask services will be under the route of /API, just to separate it from the any other routes. And again, I'm going to have the Angular application up in the top level of the route, so just under the /route, so it shouldn't clash with these APIs. So that's all set up. As usual, I just do a reload anytime I make changes to things to do with Apache and Flask. And this is the new services. So you see things like the Renogy status now. I've expanded that to bring back all the values. And let's have a look at that running. So it'll be Solar is my host name. API is that new route, and we're interested in Renogy status. I've got it here, and that's what it's returning now. So that's all working, and we can just have a look at some of the other APIs. So we've got Renogy status, we've got Renogy history. So that has two optional parameters, so you can just call Renogy history and just get the last 24 hours of history. If you put in a slash and then a start time, and that's a epoch time, so number of seconds since Unix epoch, you get it all the values up to now, starting from the whatever time you put in, and then the third variation is you can put in a start and end times and just get that range. So one thing I had to do in here was the get log data returns a tab delimited string, and I take that and I break that down to build up a dictionary object, and then return that dictionary object in data. and Flask automatically converts that to JSON. So let's have a look at that working. So if we just do Renogy history with no parameters, see here we just get 24 hours worth, last 24 hours worth of data. So maybe I only want to start from in the morning, whatever that time was. So we'll put that time in. So now it just starts from that time, and maybe I only want to go up to this time here. So this is the end parameter. If I put that in, it'll only go up to then. So we get our shorter list. And the other thing I put in here was some value checks. So if I put in some invalid value, it comes back with a status 400 and tells me where the errors were. The other ones I've got in here is for setting the webcam. So I pass webcam and then either an on or off value parameter, and it'll either turn the webcam on or off. Same thing for the rig, turn it on and off. Again, it's got some errors checking in here where if the state's not on or off, it'll return a status 400 with a explanation. Solar cache, so this allows me to look into the solar cache file, which is useful. So let's try, we'll turn the webcam on, it's already on, but we'll turn it on and then we'll have a look at the cache. So it'll be, let's look at the cache first to see the current state. And I've got it turned on because I've been playing around with this and it's got a value in there. So instead let's turn the rig on. The rig's not turned on at the moment, so let's turn the rig on. So let's go to API rig, turn it on. Okay, and that came back with a 200 value. Now let's look at the cache to see what that did. So you see for the rig now, it set an expiry time, and the rig's on for true. So let me turn the rig off just to clean things up. And if we look at the cache again, see the rig's gone back to being turned off. And the other thing to look at here is for setting cache value. So let's have a look at this one here. They're all much the same. But if I want to set one of the settings, so something like the power save level, so what happens is if the battery gets below this power save level, which is a percentage, so I've got some checking in there. So say it gets below 50% level, then I want to turn off anything that's turned on just to save power. So that'll be what I call it with. So it'll be cache, power save level, and let's set it to 70. You saw it at the moment it's 70. Let's change it to some other value. Let's change it to 50. So if the power goes below, battery goes below 50%, then the solar daemon will do some things to turn extra power off to go into sort of minimum power mode. So those all look like they're working. So the web services are going good enough for working on the Angular application. So next video I'll have a look at getting the Angular application going, so there's an easier way to connect to my solar controller and see what's going on. But one more thing I wanted to have a look at, the shed's been running for about 10 days now. You can see it here. So this shows you sort of the peaks and troughs and battery over the 10 days. So it really follows what I was showing in the last video, that when it gets charged, it goes up to 100% battery capacity. By the end of the night, goes down to close to 75%. Can vary a little bit, but mostly it's been fairly regular over the last 10 days. And you can see once we get to the morning hours and the sun starts shining on the solar panels, this orange line here shows the power coming in from the solar powers. panels, and where it quickly boosts the battery up to 100% again. The interesting thing is, depending on how low the battery is the solar panels, it'll take different amounts of power from the solar panel. So here you can see at one stage it took 25 watts almost per hour off the solar panels. Other days took less. Most cases we're getting about the same amount of sun, and it's kind of best case situation at the moment. I'm doing this in July, so there's a lot of sun. So really the variability here is mostly about how much power is needed to recharge the battery rather than how much power is being delivered by the sun. There was a couple of days in here, about here, where there was some cloudy days, so it took a little longer and less power from the solar panels. And finally down here you can see the load, so it's the same pattern as we saw last time. When the webcam's on during the day, we're using about 2 amps of power, using this access here. Right at the end of the day, just when it starts to get dark and the solar panels are still getting a little bit of light, the webcam turns on its infrared light, so it suddenly has a big step up in power usage. But that doesn't last long. Once the solar daemon realizes that it's nighttime, there's no power coming off the panels, it shuts down the webcam altogether. So overnight it's running about 1 watt per hour. And then in the morning you see it start ramping up, and it's doing that over and over again. So one thing I can tell from this, at least at the moment, is I'm using about 25% of the available power in the battery per day. So kind of tells me I can run for 2 days before I get down to about 50%, which is kind of as low as I want to get to with a lead acid battery. So it should be a little bit of headroom there, but again, this is July. There may be a totally different pattern in the middle of winter, so but it's good to get this data, and then I can see what's happening in the winter, and decide then whether I need more panels or move the panels around, something like that. But looks like we're good to go. So again, next video is going to be on the Angular client, talking to the web services I just put together in this video. And one last thing, just keep myself honest. So in our checklists, saw in video 1 I set up this checklists of things to do for this project. So let's just see where we are here. So I finished the initial planning, checked that off, set up the basic solar power in the shed, so I've done that, put the panels in there, got the basic panel and things in there, and this is the one I'm on. So mostly done this interface up Raspberry Pi to solar panel controller. So I've got the RS-232 interface going. I've created the web services now, so the last part is to create this Angular application. Like I said, be doing that in the next video.